In this step-by-step guide, I'm going to reproduce William Gosset or student's data published in the article, The Probable Error of the Mean. And he presented this study with drugs, drug 1, drug 2, and then the variable was how many hours of sleep taking the drug increases. So if it is positive, it means more hours of sleep. If it is negative, it's less hours of sleep. And they applied 2 drugs to the same patients. So we've got 1 column for drug 1, 1 column for drug 2, and then 1 column for the difference. We actually don't need the column for the difference to run the analysis, but it's useful to have it. Now, first thing, because when you replicate these old studies, you always have surprises. And the first surprise is that we need to make a correction to the analysis. Look at the data of Gosset. Look at patient number 5. With drug 1, minus or negative 1 hour, so 1 hour less of sleep. In drug 2, 0.1 hours less of sleep. Difference 0. Okay, that's just a mistake. So obviously for having a difference of 0, this has to be 0.1. In fact, well, I could have corrected this, but I did by putting this 0.1, then you get this mean and this standard deviation. In fact, the other surprise is the standard deviation. So when I show you the standard deviation analysis, you'll see a difference. And I'm going to explain why, because it's quite interesting. So let's go to the paired sample t-test. Paired samples t-test. So we've got drug 1, and then JASP asks us to present the pairs when is a pair samples t-test or repeated measures t-test. So remember that it's different for the independent samples t-test. Okay, so we put drug 1 and drug 2, and immediately JASP calculates the t-test. Now, let's go to descriptives. We tick descriptives here, and then we get for drug 1, the mean, and the standard deviation and the standard error. For drug 2, mean, standard deviation, and standard error. Okay, let's compare with the Gosset's paper. So mean 0.75, and for drug 1 and drug 2 is 2.33. Mean 0.75 and mean 2.33. So that's correct. Now, what about the standard deviation? We've got 1.79 for drug 1 and 2 for drug 2. Let's see what we get. Standard deviation 170 and standard deviation 190. So why is it different? Well, in fact, what Gosset did here, or he presented here, is correct, and what JASP is doing is incorrect. But is incorrect in a way that is everybody, all software, including R, SPSS, all of them, they do this. And what do they do? So I reconstructed how Gosset got the result, and we get this result, and it is what I suspected. Basically, remember that when we calculate the mean, we sum all the values and we divide the values by the number of values, divided by n. So that's an average. And for the standard deviation, then what you do is you subtract the mean from all the values. That gives you a measure of the distance from the mean, but then you square those values to avoid the negatives. And then, so we obtain the variance first, and what do we divide? We divide by n minus 1. And I always was curious, why do we divide by n minus 1 and not divide by n, so we get an average of the distance between each value, between all the values and the mean. So that would be nice. Well, I found the solution in one book in statistics by Navarro, and in that book it shows what's the issue there. The issue is that the correct way of calculating the standard deviation of the sample is dividing by n. But we rarely are interested in the standard deviation of the sample. We always use the standard deviation as an estimate of the standard deviation of the population. And statisticians found out that when you calculate standard deviation divided by n, that's not a very good, or rather than not very good, it's a biased estimate of this standard deviation of the population. So what they did is to divide by n minus 1. And by dividing by n minus 1, that is an unbiased estimate of the standard deviation. So then people started calculating standard deviation divided by n minus 1 and reported that as descriptive statistics. So to me, the correct thing is to do the standard deviation divided by n, and that's the descriptives. And when you want to do estimation, you do by n minus 1. But nobody does that. 99.9999% of people or articles would calculate divided by n minus 1, and all the software, including R, which tends to be more progressive in changes, they do calculate the standard deviation dividing by n minus 1. So that is the difference, and it's interesting to see the historical papers, because you find these differences that help you understand what the types of analysis that they were doing. So let's continue. Let's assume that we continue with the modern way of doing the standard deviation. Now, because of this change in the standard deviation, my t-score with JASP is slightly different. So we've got minus 4.06, and in the paper, I calculated the t using the standard deviation. Student doesn't provide the t-test, as I mentioned before. It provides the just divided by the standard deviation, not using this component. So it didn't provide the t-score, so I cannot say that my t-score, that the t-score calculated here is the one that student provided. It's not. But so the one that I did based on this standard deviation published here was, as I mentioned here, 4.89, and the one calculating with JASP is 4.06. In both cases, these are values that are far from the mean of the distribution, and the p-value in this case is 0.0028. So it's a bit lower than the one calculated using the standard deviation that student provided. Okay, so basically this is it. We've got this the descriptive statistics, this mean standard deviation. This is the standard error of the mean, and we've got the t-test, the degrees of freedom, and the p-value. We can have more information. Location parameter, it shows the mean difference. Okay, so we've got the mean difference is minus 1.58, and the standard error of the difference is 0.389. And we can have a confidence interval over that for the difference. So the confidence interval for the difference is minus 2.45 or 46, and that's the lower bound, and the upper bound minus 0.7. Okay, we can have descriptive plots that shows us drug 1, drug 2, and some measurement of variability here.